Welcome to the AgEmerge podcast, brought to you by Ag Solutions Network. Your farming challenges are unique, so your practices should be too. We're here to share emerging ideas, build connections, and provoke conversation.
Get ready to improve your soil, your crops, your livestock, and your family's livelihood. I'm your producer, Kim Chase.
And I'm your host, Monte Bottens. Thanks for joining us.
Before we jump into the podcast, we'd like to let you know about our AgEmerge Summer Summit. Mark your calendars for August 4th and 5th. Come see Monte in person and experience soil health and regenerative agriculture in action on the Bottens family farm in Cambridge, Illinois. From the basics to the wild side, get your questions answered and engage in thought-provoking discussion as we share years of experience in a full transparency farm tour. Oh, and we can't be all work and no play. So to wrap up the event, we'll spend a fun evening together in the pasture to enjoy dinner and live music at the 4th annual Concert with the Cows, hosted by Grateful Grays. So to get more information and register for our event, head on over to our website at www.asn.farm. And now, on to our show. Thanks for joining us. Today we welcome Dr. Fatma Kaplan. She is the co-founder, CEO, and CSO of Pheronym. Not only is she an entrepreneur and accomplished scientist with experience in biology and chemistry, she also has a passion for understanding the intricacies and behaviors of both parasitic and beneficial nematodes. Monte and Fatma explore everything from nematodes in agriculture to nematodes in space. Yes, you heard that right, space. Dr. Kaplan conducted the first agricultural BioControl experiment in space at the International Space Station in 2020. Now that's an awesome story. So let's jump right in.
Welcome everyone to this episode of the AgEmerge podcast. I'm excited to be joined by Dr. Fatma Kaplan. Welcome, Fatma. How are you doing today?
Thank you, Monte, for this invitation and opportunity, and I'm doing fine.
Well, that's great. Fatma is the founder, the CEO, and the Chief Science Officer, CSO, of Pheronym. And it's an interesting company that is taking a whole new approach to all things nematode. And I know everybody is excited to hear about nematodes. You stay awake at night thinking about nematodes, but no, most people think nematodes are bad and we want to kill them. But believe it or not, there's good guys out there too. So Fatma, I want you to kind of just walk us through a little bit of Pheronym and how you got started, your background, your story, what brought you to today, and all the exciting research you've done on nematodes.
Well, Pheronym start has a lot to do how I grew up. I come from a farming family. My grandparents were hazelnut farmers, and they had hazelnut orchards, and I have really great memories being at the farm. And I also know about the pesticides and pest control, how much it makes a difference in farmers' life and the productivity. And I remember my grandfather mentioning about using the pest control and how much their yield improved and increased. And since knowing that, I started a College of Ag, and from there I had the opportunity to come to US to do Ph.D. And after I did Ph.D, and I had this great opportunity as a postdoctoral training in chemistry to identify pheromones from this microscopic roundworms called nematodes. And of course, at that time, I knew about the bad guys, the ones that attack plant roots, because it nearly wiped out wine industry and grape wines in my home country. So I thought this is a great opportunity. If I'm able to identify the structure, then we can use pheromones to control agricultural pests. The reason for that, I knew about the insect pheromones and how effective they were used to control insect pests. It was eco-friendly and it didn't harm non-target pests or non-target organisms, the good guys and the pollinators. And I thought nematode pheromones could do the same thing. And from there, when I identified the model nematode called C. elegans, it's sex pheromone, USDA hired me. And it was in 2008, and methyl bromide was removed from the market or phased out. That farmers needed a solution to control the bad guys, plant parasitic nematodes, specifically root knot nematode. It turns out that now it's 2 years ago, we did customer discovery and we talked to farmers, and farmers' problem with the root knot nematode has not been solved. They're still looking for solution ever since methyl bromide is removed, which was bad for the environment, and they still don't have a good solution. While I was at the USDA, initially our thought was, let's move this mating pheromone to a root knot nematode because you can disrupt mating in insect and have a good control. It turns out that root knot nematode did not use mating. So it just reproduced. So we couldn't use the mating pheromone approach, and we thought we should look for other behaviors. Are the nematode pheromones regulating other behaviors? Where we found out that dispersal behavior. And then from there, in this case, I stepped back and looked at the good guys. That was the time I learned about the good guys. These are they're called beneficial nematodes. They're commercially available and to control insect pests. And they had a problem with efficacy. Sometimes they really work great, sometimes it didn't. And it turns out that the dispersal behavior of these nematodes regulated by pheromones. And we thought we could actually use pheromones to improve their efficacy. So that is, while I was at the USDA, I wasn't thinking about starting a company, and the seeds for Pheronym were planted. My idea there, the USDA politics affect your life the way you never imagined. So the politics, USDA started shrinking. And I thought, well, I could pursue this mission and the goal at a university, work with extension scientists who are working with farmers, and pursue it as a faculty, maybe do some portion as a basic research, learn more about the pheromones, and at the same time work with the extension scientists and collaborate with big companies to bring this technology to the market. Well, it didn't work out that way. And then while we were writing grants, and I had collaborators at the USDA, the other branches, and they said, this really has potential. And the scientists were working with these good guys that controlled insect pests, and they were working with farmers too. They actually knew the problem, and they had the same thinking that I did. They said, well, could you write a grant? And let's pursue this. And then all of a sudden, well, I didn't really know how to submit a grant all by myself. Then we started a company, and from there, I didn't know I was a scientist. Yes, I did have, farming background, but having a startup is very different. So we read a lot about it. Then we got into an incubator in Florida. It was a University of Florida incubator. They started accepting regular citizens. And we had mentors. They helped us out for the pitch presentations and how to pitch to investors. That was total new territory for me. And we thought the goal is to bring this technology to the market. If it's not university system, if it is not USDA, but there are other ways. And it turns out that it was at the end Pheronym. And we got our first funding in 2017. It was an SBIR grant from USDA. And at the same time, we got funding from IndieBio Accelerator. They said, well, we have to go to San Francisco for 4.5 months. For this program, we thought this was, grant funding, accelerator funding, synergizes. We can show proof of concept that with the pheromones, we can actually manipulate nematode behavior and improve their efficacy for insect control. And when we got to San Francisco, it was like, wow, this is an ecosystem. And for entrepreneurs and the whole, entrepreneur ecosystem, we thought if we're going to make this technology work, that's the place. And from there, we got connected to UC Davis, and we got into UC Davis HM Class Incubator. That was very beneficial for us, and to put one leg in California. Then we moved our lab completely here. Now we are in AgStart. And since then, we've made a lot of progress. We showed that pheromones can improve beneficial nematode behavior and efficacy in the greenhouse against pecan weevil and citrus weevil, and 2 other insect pests, black soldier fly, and some of the model insects. Then this year we showed it works in the field even when the temperature goes down to 10 Celsius. Biologicals work very effectively, and they do have limitations. Like every method, with beneficial nematodes, they work really well at the temperature 25. Once you go above and below that temperature, the limitations kicks in, and pheromones improve those limitations. At 10 Celsius, the soil temperature, it's in the field, and it worked really well against pecan weevil. And that was the highlight of our time. And then the next challenge we had was, what about production? And people used to ask, well, can you license it? Then we thought, well, in theory, we could. And then we realized, well, if we licensed it to a company, where are they going to buy the product? There is no commercial manufacturing for the nematode pheromones. Then, well, as a scientist, we didn't really think about it initially, but as a business person, it's like, oh, we need to have a supply here. Then we wrote a grant to NSF this time for manufacturing. And we went through a number of things, how we can make the product, but it should also be cost effective, that we can actually make money. And if we can't make money, then it's not going to be staying in the market. So recently, we were able to show that, yes, it works. Our new method, which is scalable. Now we have a scalable manufacturing method, and we are getting ready to submit our phase 2 grant to NSF, and at the same time, going to be raising funds from investors.
Fantastic. It's an amazing story of where you've been and where you've come to, plus all the great foundation you've laid for what's looking ahead in the future. So there's a lot to unpack on there, and I was kind of taking some notes as we're going along, just so that we can make sure everybody's up to speed on everything. So you mentioned methyl bromide, and that is a soil fumigant. So our traditional way and our traditional thoughts of how we approach things, right, is if we have a problem, we try to kill it. So methyl bromide essentially takes out anything living within the soil, not only the nematodes, the root knot nematode that you're trying to target in this case, and a lot of it's used especially in carrot production or other soil-borne or soil harvested things, especially because they can have such an effect on them. Plus, like you said, in grapes or almonds or any other crop, those parasitic nematodes can have quite an impact. But methyl bromide is also very active as far as I believe a greenhouse gas. So it gassing off to the atmosphere is why it got outlawed in California from use. So I think there's maybe some special exceptions here and there, but it's largely gone. So that tool's out of the toolbox. So we've tried to replace it with, there's a host of companies coming up with steam, electrolysis. They do solarization, where we till the ground over and over and over again to try to get it to sterilize the ground. Or we use plastic culture, to where we're trying to heat it up so much or suffocate it, or all kinds of different approaches. And so that, what you're researching there is, so you found this pheromone that was basically a mating pheromone, thought, hey, here we go. We're going to apply this to root knot nematode. Then they don't respond to it. See, that's just not fair. But, the unintended consequence is you found out that basically you were stimulating the ones that actually feed on the root knot nematode. Is that a fair way to say that, Fatma?
Not.
How does that process work there because you couldn't disrupt the mating of the root knot nematode? How did that initial discovery come in to help with the control of that?
So for the root knot nematode, we also learned quite a bit from the biology that helped us out how to control them. It turns out that they actually know which plant is infected, which one is not infected. So if the plant is infected, it has nematodes on it. And the nematodes we know communicate now with the pheromones. And at that time, that was the thinking that if they're communicating with each other, then and it was also shown that if it's infected, they prefer the healthy plant, uninfected.
Yeah, they want to go where there's fresh food instead of where everybody else is hanging out, right?
Yeah. What if we said to nematodes, this plant, this healthy plant is infected using their own pheromone, even though it's not? Then it would say, it would just make a decision to go away, looking for some healthy plant.
Excellent.
And eventually, because at that particular life stages, they have a limited resource of their own. They don't feed on anything until they find the insect. And we thought if we keep them long enough, they will run out of their food and they will die. So, and it doesn't, yes.
Right. I mean, it's simple, but that requires a significantly different way of thinking to solve the problem, right? Because everything else up until then is, bang, bang, bang. How do we kill it? And now you're looking at, okay, how do we just avoid it and essentially starve it out?
I would also say having a background in farm makes a big difference.
We're taking a short break to share that the AgEmerge podcast is brought to you by the team at Ag Solutions Network. Rooted in innovation, ASN is committed to leaving the land better than we found it, not simply maintaining it. We're here to help you navigate the balancing act of productivity and building a legacy. From practices to products, ASN is more than a new jug. It's a new way of thinking. So don't be afraid to be different. Be afraid to be the same. Contact Ag Solutions Network today at asn.farm. And now back to our show.
Yeah, that's amazing how, just thinking differently in that approach really changes everything. So let's back up a little bit. Talk to us about pheromones, what they are, what their chemical composition is, how they're made in nature, just kind of a little overview of Pheromones 101. And not for the guys that thinking they're buying the pheromone cologne and to get a date, stuff like that. So this is a real science and what's behind it. Just share with us a little bit about what pheromones are, how they work in nature.
So pheromones are small molecules. They are released from one organism and affect the behavior of the other members of the same species. Well, in layman's term, it's communication signals. You and I communicate by using our voice. Nematodes communicate with the small molecules. And in our case, we speak nematodes. So that would be we tell them, hey, there's good food source here. Come on over here. Or no, the conditions are really bad here. Don't come over here. Or the conditions are going to go really, really bad. Then you have to get ready for the harsh conditions. Then they turn into this alternative life stage. So these are small molecules insects use to communicate. And now we know nematodes also use to communicate.
So, and along in your process of everything that you're learning on how to tell plants what's already been taking or fake them into not attacking certain plants, you also mentioned the beneficial nematodes and the work done there, and how in the past it's always kind of been hit or miss. And let's say in organic production, there's not a lot of options for nematode control. So beneficial nematodes are kind of what you use, but it's not the greatest, it's expensive, and you got this hit or miss going on. And you mentioned you've had a significant improvement there. So what kind of changes have growers seen in the improvement overall, not only in that temperature range, but just in efficacy and consistency of beneficial nematodes using Pheronym products?
So currently we are not in the market. We are working with USDA scientists and University of Idaho. They do the trials for us. With the beneficial nematodes, we are looking at insect kill rate. Beneficial nematodes are good guys, and they control the insect pest they can actually kill within 24 to 48 hours in laboratory conditions. And in the field, when they're effective, they're actually really fast. Within Yeah, within 2 to 3 days, they can kill the insects. And as you mentioned, sometimes it works, sometimes it doesn't. When we talk to scientists who are doing in the school grounds or other farms, and there are many publications. And it turns out that one of the behavior that is affecting this efficacy is dispersal to search. So this happens within 2 weeks after they emerge, let's say, from an insect cadaver they consumed. Then for about 2 weeks, they're searching. And then they stop when they can't find any insect in the near vicinity. So when the farmers receive these nematodes, they're in that mode, they're not searching. Their power is to search and attack the insects. So with our pheromone product, we remind the nematodes that they're hungry, they need to go out and search. So farmers, when they receive the beneficial nematodes, they add our product and they say, yes, we are ready. So they can also smell the insect pest because that's in their nature. It's like the targeted missile. So you put them in the field, they're ready to search, and they can go 35 centimeters deeper. That's we tested, we know. They can go deeper in the soil too. So even if the target pest is running away, they will find an infect.
I love how you make all of this so fun. I mean, at a microscopic level, it's a world that's unseen. It's very complex and complicated. And Fatma, you do a wonderful job of explaining it in a way that everybody can understand. So I really, really appreciate it. It's almost like you're making Red Bull for beneficial nematodes. You're giving them getting them going. So that's excellent. And but no, so it took a lot of work to get here, and you mentioned the incubators and that you've been a part of, and then the first incubator, then you went to San Francisco as a part of that incubator. Explain that incubator process, what that's about, and why is that so critical to bringing new ag technologies to market? What all does that bring together when you come, like you said, many people come from an engineering background, or you from a science background, and to make that into a product and a business. Share about that a little bit, how that incubator process works, and what are some of the impacts it's made on you and your company.
Oh, incubators, I would say, really essential. When you have a biotech company, we have this huge barrier, infrastructure barrier, and that requires money. And when you're just trying to show that the proof of concept, whether it works or not, if you don't have that infrastructure, it becomes impossible. Incubators have that infrastructure, just like universities or at the USDA. And then we don't have to do this huge investment for something we don't really know whether it's going to work or not. So that eliminates that huge barrier for us. So all the funds we raise, small amount, is if it's working, then it's go or no go. Once we show the proof of concept, we know it's going to work, then we can feel a lot more comfortable to raise funds. Same thing for investors. It's a huge risk for them to put a huge amounts of money and just to see whether it is going to work or not. Incubator helps the biotech companies, I think also in some ways to investors, that we are de-risking the huge technological risk. Right. Then, like you mentioned, some of us engineers, scientists, we don't know how product development works. Afterwards, let's say we show the proof of concept. How do we bring it to the market? There are so many different parts to it. And the mentors at the incubators are very helpful. There are different kind of incubators. And then we don't, sometimes we don't even know how to talk to investors. And I remember the first time when I was preparing a pitch deck, I had no idea. How do you present? What is the presentation? What are these ins and outs? So it was the first incubator that showed it to us. And, you show the problem, then your solution. How are you different from the others? Is there actually a demand? As an academic, I go to the literature first, market research reports. Those are good. They're very valuable, but nothing is like actually talking to the farmers or the people in agriculture ecosystem supply chain, what the manufacturers think, what the pest control advisors, which is really critical in California. That's we learned during the NSF funding. So we learned a lot and talking, what do we actually need? What do we need to focus? Even though we do have initially very generic idea, we can fix everything, but do we need to fix everything? What does actually farmer needs? Then we can actually focus our efforts to that need.
Right. And it gives you that, it almost gives you a path or a recipe to follow, right? To be successful. So that way you can stay on course and on time. And thank goodness for those incubators. And like you said, each one has a different specialty and gets things going. So now today, you're a part of the ag startup community, which a friend of mine has started there in just outside of UC Davis in California. Talk to us a little bit about this and the unique opportunity that the team has put together there in California, and what that means to you and other ag tech or biotech businesses that are starting up.
Well, it's basically existence, I would say. It makes a big difference for our existence in California or existence in general. We are still early stages, and even though we didn't raise huge amount of funds to build our own lab, now we can directly access to wet lab space that we don't have to worry about where we are going to be. As a startup, we can't really do a 5-year or 10-year lease. With the incubators, then it could be a month-to-month or it could be yearly lease, which makes a big difference when you have limited resources. And biotech requires a lot of money. It's not an app where you can have a computer or you can have a home office. You have to be in a physical place. It needs to have certain safety, up to a code for safety and many of the other things. It is not trivial to set up a wet lab. And we were very appreciative of John Cellular to taking the lead and starting this incubator. Prior to AgStart, we were at HM Klaus Incubator, which provided really nice opportunity for us. But at that time, it was a very popular incubator, and we didn't really have I think we had only 6 foot or 3 foot bench space, and it had shared equipment. We benefited and we utilized it as much as we could, but we wanted to hire more people because we wanted to grow. And there wasn't any incubator place in the UC Davis area, UC Davis, Sacramento, Woodland area with a reasonable price. Then AgStart opened and the bench prices were very reasonable and we could afford. And now we grew since then. We have 1 research assistant, 1 visiting scientist, and 3 interns. And 2 of the, one of the research assistant is going to be full-time soon. She's graduating, and one of our intern is going to be full-time, and the other one is half-time. This is all because of AgStart and the space availability. So it is helping us grow. Our next stage was, this is really important, and AgStart is expanding, and it is starting a fermentation lab. And we put our name in the list because that was our next stage. Even though we did acquire some of the resources or acquired access to resources at Lawrence Berkeley Lab, that's another type of incubator or entrepreneurship program. I should mention Activate Berkeley. Now it's Activate Anywhere. They have offices in Berkeley and Boston. The Berkeley office is the one we are in that gives us access to Lawrence Berkeley Lab and ABPDU, where there is a facility. We have access to transition from shaker flask to bioreactors and scale up.
So I think it's really interesting, all of these components that you have really synthesized together to make your company come to fruition. So it's not only the science behind it, but like you said, it's the proof of concept, and then also the business plan and bringing in capital and all these things that you can definitely tell you're a lifelong learner. And the other thing is it's unique in your space, is like you said, it's not just push an app out to an Android phone or an iOS phone, and you magically have, a distribution model or a production model. You're also now in the process of figuring out how to make the machines to make your product, in a simplified way there. So, I mean, you've got kind of two layers of complexity in your production model, right? And you've made some progress on that.
Yes.
So that's very exciting to hear about. So that's just an extra layer of challenge that's really interesting. But now that you have that, you'll be able to probably your products you think you'll license or have someone produce for you on your behalf with the technologies that you've developed, so that then they can reach a farmer to make the difference, correct?
Yes. We also looked at the business aspect. We are moving, it has so many different parts with the startup, which I have never imagined I would be doing. So we're not just focusing on the science, we have to focus on the business side all at the same time. Even though we don't really have a package, pretty soon we will have a packaged product that we can actually share with potential customers. We're working with distributors and who's actually specialized in biologicals, because we have learned when we had the customer discovery calls and the interviews with agriculture ecosystem, we realized some of the distributors are very good with chemicals, some of them are with biologicals. And then we realized some of them directly target row crop growers, some of them specialty crops, some of them specifically greenhouse growers. Then we started which insect pest we can actually get into the market. And then we identified thrips. And thrips is really unique because it developed resistance to chemical pesticides. And then the next question is, does our solution addresses the problem? Because we had several different insect pests identified, but thrips, our solution also solved farmers' problem. Then the agriculture being seasonal, then we thought, how can we get our product into the market that eliminates the seasonality problem? Then this thrips was a pest, is a problem in greenhouses, where season is not a problem. And one other advantage of the greenhouse, when we were talking to the distributors, they said, you can do a field trial in one greenhouse, doesn't matter where. It's applicable to all the greenhouses throughout the world. But that is not the case for other pests. If it's a field pest, you have to do field trials. And when we talk to the distributors, when we talk about field trials, they mentioned 40, 50 field trials. And I thought, okay, so let's see what we have and how we can get into the market the fastest and the minimum amount of work, but that would still not cut the corner, but properly done. Trials, then would get into the market, show that the customers it is working, then expand from there. So that was thrips was one that is globally opens up the doors to us globally in the greenhouse growers. And then actually it is a problem for other specialty crops in the field. Then we thought in the meantime, we can still do field trials in the field. So we have learned a lot. As a scientist in the lab, maybe 3 replications or 3 experiments might be enough, but not for the field trials.
Well, I think that shows the focus that's needed by an entrepreneur. And, you really looked at that market and realized that, hey, we don't have the capital or the runway to do 40, 50 field trials. And plus, it might apply in Salinas, but it doesn't in Western Fresno County, or it doesn't in, Sacramento County or somewhere else. So, but like you said, in a controlled environment, hey, if we can do this, we can solve a problem in greenhouses, we can adapt it worldwide quickly, and you create the minimum viable product, right? So that you've got some cash coming in the doors, to where then the next iteration you can go to those field crops, if you choose to, or you go to, the next bug in the greenhouse instead of the thrip. So, yeah, I love how you've narrowed that down. And for the other entrepreneurs listening to the podcast today, boy, get it down to we all want to do everything for everybody, right? but it's
Yes.
hard. I can imagine how hard that was for you to do that. But the discipline's definitely worth it, isn't it?
I think that comes from the farming discipline. It's the planning. We learned it at the farm when I was growing up, managing, helping my grandparents and my mom. And, if you don't get things done on time, you're not going to be able to harvest. I think discipline comes from there.
Well, speaking of farming, I did have an opportunity to, you came back to our farm last year in the summer. We offered what we called our Summer Summit. We're going to do it again this year. And there's ways that you can register for that. Kim will have that in the show notes. But, really in Midwest agriculture, what were some of the things that you saw here that you found interesting, or some of the other people who you got to talk to at the event? Describe your experience a little bit.
That was actually really amazing experience, I would say. Even though we did talk to the farmers during NSF I-Corps program, but nothing is like visiting the farm. And, my grandparents were, a specialty crop. Hazelnut. Yes, they did grow some wheat and corn, but it was small. It's just for the family. It's not like big farms like you had, or there's like acres and hundreds of acres. It was really amazing the way actually at your farm the soybean was grown and how the wheat was controlled and how much experimentation was there and how much you cared about your soil and the land and that connection with the land. And I thought, when you're a farmer, when you run your own farm, it's a very different connection, caring about the land and how much the topsoil was eroded over years and years when you mentioned it. Now you're nurturing the farm and the yield started increasing. That was really amazing to hear from a farmer and at the farm and seeing the difference.
Well, it was fun to be here and fun to show you what we were doing, and we've upped the number of trials and tests we're doing again this year. So looking forward to hosting others, and everyone's welcome to come and see those things. And the biggest thing is, I think a lot of times for anybody, you just need to be able to see a different way of doing things before it catches or before something you want to try. So that's what we hope to do, is just provide an opportunity for people to think and do different, but converse with other people in the group too at the same time. So I'm sure glad you were a part of that. When you're looking forward to the future and you think about what some of the potential impacts are on the work that you're doing today, what do you, let's say 5, 10, maybe even 15 years from now, when you look back on the impact that you've had, what do you want that to be?
I think the nematode pheromones, since we are working on it, I think will make a big impact because it really expand the application of the pheromones. The current pheromones are volatile from insect and they target the pest above ground. With the nematode pheromones, we are bringing the pheromone applications to underground soil pest, where nobody sees, when you don't see it, it's kind of like out of sight, out of mind. But farmers know, because when you harvest, it's like, oh, where's my yield here? So soil is just as important as the air we are breathing because they're all very much interconnected. It also had the nematode pheromones are different from the insect pheromones because we can dry them and we can store them as dry powder and they're water soluble. So it can improve the existing biologicals efficacy and it creates a composite biopesticide, we call it, Nemastim plus beneficial nematodes, and it can be applied to seed treatment. It's already active in very small amount, let's say 2 to 3 grams would be applied to an acre of orchards. It's a lot less, and it doesn't stay in the environment too long, so it keeps our soil healthy. It is friendly to soil beneficials and soil microorganisms, and it is non-toxic. and it's healthy for us, I think I see a very bright future for both above ground and below ground insect pest control, or in general pest control. And it can also target just specifically the bad nematodes, not the good guys. It's good on the good guys, good nematodes, and controls the bad guys without harming the environment. It's bee friendly, pollinator friendly, and I think it will take off in the next maybe 5 to 10 years. We are going to be seeing it in the stores, and it's going to be just mainstream, like the insect pheromones. Oh yeah, nematode pheromones. They work for this pest and in the greenhouse and in the orchards and the row crops.
I love it, especially on the seed treatment like you're talking about. Today on our broadacre commodity crops, many are including a seed treatment for soybean cyst nematode or for corn root knot nematode. And while it does target those species, like you said, there's always the unintended consequences. You try to kill one bad guy, but you're killing potentially all the other good nematodes that are out there, and we don't think about good nematodes. You hear the word nematode and you're like, ooh, that's bad. But it's this blanket coverage where what you're doing can be very specific on, because every nematode's using a different communication pheromone within their species. So that's so exciting. And not only can you do the repelling, but you can also, call them in or what it's the whole communication. You've opened a literal can of worms, but they're very, very small worms. So, I mean, I thank you for that, because it's going to get more pesticides out of our production model. And most of those nematicides are also systemic throughout the plant. So, like you said, can have adverse effects on pollinators and those kind of things. So that's exciting. I love it.
Yes. Sometimes people say, how do you compete with the chemical pesticides? When we were talking to farmers and big farm managers, some of the chemicals, they might be very effective, but farmers didn't really have access in California. It might be close to a school region. So we are actually addressing a real need. It's not replacing it, but there is a need that farmers really need that eco-friendly solution. And we learned that last year in New York, school grounds, they cannot use chemical pesticides because it's a school ground. And then they really didn't have any solutions. And the Cornell extension faculty was working with the school grounds. How can we control? And they had only one option, actually, that was the beneficial nematodes. And they said, well, can we do a trial with you? And I said, yes, we can. Now we are working on improving and scaling up. And I said, let's put it on the schedule. Now, actually, we had farmers group and working with university scientists from Tennessee, and they reached out to us. And through USDA, we're working on flat-headed apple borer. And there was another one, another interest on Ambrosia beetle control. So it is getting a lot more popular, and people are learning more about it and reaching out to us.
Yeah, so you're on those insects, then you're basically stimulating the nematodes to attack the larval form or when they hatch in the soil during the soil portion of their life, I assume?
Yes.
Okay, excellent. So see, there's just, we got to open our minds on how we can solve problems. And I really appreciate what you've done there.
It does one other thing. If the insect has a life stage that is in the soil, sometimes they overwinter in the soil, it attacks those life stages too.
Interesting. The soil's not safe for any pest now.
Not anymore.
Well, let me ask you another note. There's some things that, I've noticed, and I've enjoyed being, knowing you now for a period of time. But, there's a lot of challenges for women in your roles. You are a scientist, which is fairly male dominated. Entrepreneurship, several of the pitches that I remember hearing, it's 90% plus male dominated category for founders that are seeking funding. and in agriculture. Still, it's a very male-dominated industry. I mean, probably one of the most. So you are bucking the trends here, and I'm glad you are. I'm very excited about that. What would you suggest for other female entrepreneurs, female scientists, female ag tech startup as encouragement? Things that you've looked for that has really helped you succeed despite the extra obstacles you've had to overcome?
I would say we benefited from incubators, accelerators, and mentors. Always find positive people who believes in your mission and opens the door for you. Sometimes they might sponsor, and I would say you can never have enough mentors. And there are, people out there who are really supportive of the technology, and try to have a couple of women mentor too. The reason for that is if they accomplished it, they have some tricks in their sleeves. They know how to avoid testing. Yes, if you're, experiencing, hardship, but they also went through those things and maybe benefit from their scars sometimes. They may not have been successful, but in some areas they have success on the others. If they're successful, that's definitely a good recipe to success. But even if they didn't make it at that time, they tell you, if I had known it, I would have done it this way. So, one way wasn't successful, but they already thought about how they could succeed. So definitely benefit from their, experience. It's both, I think, we had really good male and female mentors and who were really positive and believed in our mission and goal. John Salep was one of them. And I'm so glad, actually, he's very open-minded. And this incubator, the current incubator, is very welcoming to both women and men as an entrepreneur. And we actually have two female CEOs here. One is me, the other one is Turtle Tree. And let's see, there are a lot of women. It's a very good mix.
That's wonderful. I'm glad to hear it. And I love how you're saying don't take the negatives, but focus on the positives and seek out those who will help you and just, always just be persistent and be positive and you can make it happen no matter, what the circumstances are. So I think that's a great advice for anybody that's looking to start up or pursue a new opportunity. So it's pretty amazing. All that can be done when you stay positive. So, I've enjoyed being a part of your story and hearing about it. What other things are coming up here in the future? Other things maybe I should have touched upon today during our time together that I maybe didn't yet.
Let's see. I think we pretty much covered everything. Well, the most recent one, I would say, the space one, we probably
yes, I forgot to bring that up. Okay, so, believe it or not, this is interesting. You have sent nematodes into space, right? And I even got a coffee cup from you with the mission logo on it and everything. Tell us about this. How did that came about and what that was all about?
It started out actually in 2018. We had a project from Space Florida, and that wasn't for space. It was actually for Earth related. It was supposed to be for Earth related. And from there, I was introduced to another space group. They said, well, they're sending nematodes to space. Maybe they can help you out. And it was right about the time when I was talking to investors, nobody knew about beneficial nematodes. And I knew that it was commercial, but none of the investors I talked to. I was at the accelerator. I talked to a lot of investors. It wasn't one or two. It was maybe at least 100 of them. And nobody knew about the nematodes. And I thought, I need to find a way to create awareness for these nematodes. But at the same time, I don't have a lot of time, and this has to be integrated to our product development. So when I was introduced to this space group, they said, oh, we can send the nematodes. And the initial idea was to look at the pheromones. It wasn't actually for the nematodes, to look at the nematodes, whether they could produce pheromones. If they did, what kind of pheromones they produce, would be able to use those pheromones on Earth to create a better mixture. Then when we started writing the grants, and I asked them about whether they had money, because I can't really afford to send the nematodes to space. They said, yes, they do have some funds. And I said, well, send me one of them. And we talked about it. They loved the idea. And when I wrote the project, it was for the pheromones. And then I talked to our USDA collaborator, and I said, well, can you help us out? And here is this potential opportunity. And then we figured out that we didn't really know how the nematodes would be able to infect the insects in space. So it created a lot more basic research. We thought, well, we can still look at the pheromones, what they're producing, but we should also look at some other aspect of this, whether we could actually do a biocontrol in space. Is it actually possible for these nematodes to go through the sand or soil, find the insect and attack the insects in microgravity? And it also has a symbiotic bacteria. Now you have two organisms. Would they be able to cooperate? So it brought up a whole bunch of questions. One other unique thing about it is, people say, why are you doing biocontrol in space? And I said, well, NASA is, planning to colonize the moon and the Mars. If you're going to go there, you cannot colonize anywhere without agriculture, without food. And I said, we can't use chemical pesticides because air is really precious there. You have to use the biologicals. So if you're just going there unprepared, if you bring pests, we can say, well, everything is sterile. Why would you bring pests? And then, well, we have all these quarantines not to have the invasive pests. They still invade us. And I said, they're going to invade the space too. Doesn't matter how careful we are, but we don't really want to be caught without a guard. We should have some solutions in case they did. One other thing NASA said when I was writing there, says, oh, they do actually promote the projects before the flight, during the flight, and after the flight. And I thought, everyone listens, this might be a good place to introduce beneficial nematodes that would create a lot more awareness. So it had the science, it was the awareness that I didn't have money, but I had a source that would be creating without me spending funds. And they actually did. Some part of the project was already on the NASA's website, ISS. But there was one rule: I wouldn't really say or present or prepare anything without their approval. We said, okay, that's how the mission patch, the cup you have with the mission patch, that is approved by ISS, International Space Station. And USDA, because USDA didn't want anything out without being approved either. So two agencies did. So at the end of the experiment, we sent it in 2019, December. It came back in 2020. And right about the time, luckily, after 2 months, I think, in March, we had the COVID shutdown, but by that time, we finished many of the experiments and we were able to publish. So it was a success in every way, scientifically and toward the company, and awareness of the beneficial nematodes. Believe it or not, BASF talked to me afterwards, and they said, hey, did you know this year BASF is a big company? They highlighted beneficial nematodes in their annual research report. They said, well, we thought, if you think about it, they sell a lot of things, beneficial nematodes is a very tiny part of that, income, but they highlighted it. And I said, well, it might have something to do with us creating very awareness. I don't know whether that was the case or not, but they said they were very happy about it. The scientists we talked to, they said, hey, they highlighted beneficial nematodes even in our annual research.
Well, that was definitely another way to think outside the box, putting a lot of things together for synergy and thinking differently to, like you said, get that awareness and kind of help get a little jump start on what you're up to and what you're doing. So that's fantastic. I'm glad to hear that, you got good information back from it too. So I'm sure that'll continue to support your ongoing efforts. So amazing.
It did create visibility that I didn't really expect internationally. There are a couple of companies, they said, hey, we heard about you because of the Nematode. Nematode has its own followers.
Oh boy. There's something for everybody out there to be interested in, right?
Yes, people ask me about it, so how the project is going. And apparently when we were doing the updates, people tell me, hey, this is what happened, we follow you. And actually, I'm presenting Nematode next week as a plenary lecturer at the International Congress of Nematology in France. So I've been invited to give a talk about it. So the whole nematology community loved the project.
Well, everybody's going to know who Dr. Kaplan is, so that is awesome. So, no, I really appreciate all the things that you're doing to, like you said, not only bring it to awareness, but discovering the product that works and where to make it work, and then how to get it manufactured. I mean, I don't think there's any hurdle you can't overcome. So it's pretty impressive. So I appreciate you sharing a little bit on what all that you're up to. And really, what I'm so excited about Pheronym and the potential is that now you're giving us a biological alternative for significant pest problems that is going to help to enable the regenerative agricultural movement in a big way. So thank you so much for what all you're doing, Dr. Kaplan. It's a real joy to see it, and it's a pleasure to know you.
Thank you. There's one last thing I want to mention is
Absolutely.
When we visited your farm,
yeah.
And I have never been to a farm before who practiced regenerative agriculture. Yes, my grandparents were farmers, but they used to use the chemical pesticides. And now they're interested, but seeing how the regenerative agriculture is practiced was really eye-opening for me. It was a really important experience. I think it did affect even our decision in the company, how the farmers looked at it and how it is practiced and what kind of things we can look at it. Not just, one aspect we learned from the customer calls, but visiting farm was a very different experience and it affected our decision making.
Well, good. I hope that's a positive thing. So,
oh yes, it was.
No, I encourage you or any of the listeners, anytime you got a chance to spend time in the field, do it. It's the best thing anybody can add to a field outside of pheronym, pheromones, is their shadow. The best thing we can do is spend time in the field. So, but no, thank you. I'm glad you came. I'm glad you enjoyed it, and I'm glad it had an impact. And that's what we hope to do. So, thanks again for your time today, Fatma. It's been a real joy.
Thank you.
Thanks for listening to this conversation today. It's exciting to hear the passion and drive Dr. Kaplan has for finding ways to bring new technologies to market, and her desire to talk and work directly with farmers to find solutions that work. And if you'd like to learn more about what we're doing to help growers implement soil health practices, check out our website at asn.farm, and there you can click on links to follow us on Facebook, Twitter, Instagram, LinkedIn, and YouTube. There's a lot of great things happening and always something to learn. Thanks for listening.